Good morning, guys. Welcome to day 3 of remote learning. All right, just a reminder to stream. This one in particular is for my 6th graders, periods 1, 2. All right, today we are going to be using tables of the equivalent ratios like pros. All right. We're going to start with a warm-up that is not necessarily in our... Good morning, Brian. Thank you for joining. Our warm-up is not necessarily about ratios right now. It's more in the context of area, right? So it says, write 2 expressions to represent the area of the rectangle. Area of the rectangle. Hopefully you guys remember how to do that. How do we find the area of a rectangle? Good morning, Jesus. To find the area of a rectangle, you have to multiply length times width. Good morning, Janelle. Thank you, guys. Thank you for being punctual. Thank you for being here. All right, give that a try. We are going to, after the warm-up, Jesus, you should not actually get a number. We need an expression, and it's going to be a mixture of number and variable because of that x, and we do not know what x is. So we are not solving. We are simply writing an expression to represent the area. And this is why we're going over this, because I noticed that this is something that everybody struggled with or forgot about since December when we first started. After the warm-up, we are going to review the homework that I assigned, 11.3. So if you guys have any questions on that, you'll be able to participate or go back and look at this video. We're going to do lesson 12, 2 tasks, 12.2 and 12.4. Hopefully we have time. And then finally, after all this time, because we've completed lesson 12, you'll be able to do the classwork assignment that is on Google Classroom. It's been posted for a while. It is due tomorrow. Okay, due tomorrow. I hope you guys are doing okay out there. Anybody feeling overwhelmed or everybody okay? We're handling this like champs. Tired? Yeah. I'm gonna suggest, if your parents are okay with it, if you just like go for a couple of walks, maybe a couple of short walks, because sitting home is not gonna help us. We gotta be active somehow. All right. And try to keep the same routine that you had in school. Try to go through your schedule. Try to continue to wake up as if you had school. That'll help. Okay, well, just ask them when you can. Just ask them when you can. All right, that way you get a little active. Or you guys like video games, so maybe you know, something like Just Dance or Dance Central, or the sports things that make you move. You know what I mean? Okay. All right, let's get to the math. What do you guys think? I'll copy it down here so that you guys can see it better. Hi, Taylor. How are you? Length times width. Okay, how do I do this? How do I write an expression that is going to represent the area of that rectangle? How do I do that? Teach me. Okay, we have Brian H. Taylor, Jesus, Janelle. And 1, 2, 3. Okay, and that's it right now, right? Okay. Oh, good morning, Galen. Okay, guys, the warm up. We gotta move. Got lots to do. What do you think? Anybody have any ideas? If we're supposed to multiply the length times the width, let's first identify that. We're not going to have a number. No numbers. It's going to be an expression. Some type of mixture of the numbers and variables that represent the area of the rectangle. So we have to do length times width. Well, which one's the length? Let's identify it. Okay, cool. That's good. X plus 2. If this is our, if that's represent our length, and I'll put the label up here, this is our length, which means this would have to be our width. Let's multiply them like it says to. Let's take X plus 2 as a sum. Okay, they're a pair. They don't get separated yet. Good. Okay, good. And then we'll multiply it by 6. Now I'm going to rewrite this. And I'm going to do this. Because this is how, more often than not, especially as you get older in math, you're going to see the expressions written like this. Notice I don't have any equal sign anymore. I did that to show you how to calculate the area. Okay, so now guess what? I asked originally for 2 expressions, and this one actually counts. Believe it or not, this one actually counts. This counts as one of the expressions. How do I get the second one? You guys remember the name of the property that we use? Begins with, okay, good. Let me see what you got, Brian. I'll wait. That's the same thing as this one. That's the same thing as this one, except this would be written back here. That one's the same. I want you guys to use what we call the distributive property. Distributive property says that if I have this sum here and it's multiplied by this number, that I can distribute the 6. 6 times x is, and 6 times 2 is. Okay, so if this is the first expression, this is the second one, and they mean exactly the same thing. You guys, hopefully you guys remember that assignment from when we first started working together. I was actually out one day, and Mr. Casamento did this with my classes, including you guys. It was a handout. You guys did it. Some of you liked it so much that you shared it with your families during parent-teacher conferences. It was an assignment that went for you. That was this. Good morning, Astrid. Welcome. Okay, so let me label these. This is the first one. This is the second one. So first expression, in case you missed it, and second expression, because remember the warm-up asks for 2. So what are the 2 expressions? This one and this one. And they mean the same thing. How do you know if they're going to mean the same thing or not? We only needed 2. Okay, no problem. How do I test if these 2 are actually really equivalent? Let's pick a number to put in for x and test if we get the same answer in both expressions. So someone, good morning, Avril, how are you? Good timing. We're about to finish the warm-up, and then we're going to do 11.3. Someone give me a random value for x, and we'll test to make sure that these two expressions are equivalent. Someone, anyone? 7? Okay, beautiful. Let's do 7. So what I'm going to do is, I'm going to erase that, and I'm going to put the 7. So let's test it out. 2. Why do I have to use 2? So what is 7 plus 2, folks? 7 plus 2 is 9. What's 9 times 6? 54. If they're equivalent expressions, I'm supposed to get 54 again. So what is 6 times 7? 6 times 7 is 42. What's 42 plus 12? It's also 54. So that means that these two equivalent expressions were correct. Nice. Be nice, Brian. Okay, cool. Okay, that was our warm-up. We're going to move to 11.3, folks. 11.3 was actually homework because we couldn't get to it in the stream. We actually ran out of time. And sometimes that's going to happen because you guys have questions, and I want to put the questions first. That way you guys feel successful at home, since we can't be in school right now. All right, cool. Okay, now 11.3 looks like this. We're still in unit 2. So we're still in that green book, ratios. We're almost done though. This is actually, today marks the last day of the lesson. We're going to do lesson 12, and then we're going to review tomorrow and Thursday. All right, so 11.3. Some people had some questions. So what I'm going to do is I'm going to show you my answers, and then you tell me where you got stuck, if anywhere. Oh, Fergie's here? Hey, good morning, Fergie. All right, take a look at this right here. Take a look at the table, make sure you got the same values. And if you have a different explanation, I would actually like you to type it in chat or in comments so that we could open up a discussion. Maybe you explained it a little differently than I did. But when it comes to equivalent ratios, it's actually very, very simple. Oh, Fergie, I hope you feel better. I hope everything is okay. Hopefully you guys could see this okay. I hope there's not too much of a glare. Good morning, Nathan. I'm so happy that you were able to join us. I sent you an email with a list of all the work that I still need you to complete, sir. Please make sure that you have that completed as soon as possible. Is that a 3.50? No, actually it's 350. 350. Is that better? Is that worse? Maybe if I zoom out? Nope. How's that? Okay. What do you get? Talk to me. Did you guys get the same answers? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Yes? Okay. So Avril, hopefully you're here. Because I'd like to know what questions you have on this assignment. Any questions? In the computer. I'm going to do it. Good morning, Brian. It's okay. Number 2 and 3. What methods did you use to fill in the table? So that's actually something that you put in your own words what you actually did. So I'll give you an example. Something that I did when I first started, right? And I might just say this, right? I looked at the 7 and the 5, which is what they gave me. And then I looked for a number that was easy to get to. So for example, 7 to 28, that's extremely easy to get to. You just multiply by 4. So you can say, when you're writing your answer for number 2, you can say, I looked for multiples of 7 and 5. Because that's all we're really doing, right? We're skip counting by 7s and 5s. 7, 14, 21, 28. Now 21 is not on the list, but 14 and 28 are. Okay, cool. Now for the last one, number 3, it says, how do you know that they're equivalent? Now, if you go to the back of your book and you take a look at equivalent ratios, that answer is pretty specific and pretty much the same. As long as you have the same factor and you're multiplying it by the ratios, you will get equivalent ratios. So for example, remember I just said 7 times 4 is 28. Well, 5 times 4 is 20. And that's how you know for sure that you have an equivalent ratio. Let's see if I missed anybody. Brian, you're going to be able to join us at 10:30, I hope. If not, it's okay. You can stay here for this one and participate, and I'll still mark you down. Nathan, did you read the email? Okay. Okay, so I said that I emailed you the work that you have to do. So you have to open your email and you have to read it. And if you have any questions, you can let me know. Equivalent ratios. Look at the definition. If you multiply by the same factor, you will get equivalent ratios. So that's for number 3. Avril, does that answer your questions, dear? If anyone has any other questions, please make sure that you ask. Okay, cool. Very cool. That's what, all right, so it's working. We're doing good. That means, right, and I'll show you guys this again so you know where we're at. We've already done the warm-up. We've just reviewed our homework 11.3. So now we're on the new tasks, 12.2 and 12.4. So please go to lesson 12 in your book. It says comparing taco prices. Lesson 12, activity 2, comparing taco prices. Okay, cool. So what I need you guys to do for it says use the table the table to help solve the questions. There's 2 questions here, and it's about tacos. Yes, we are. Yes, we are skipping. 12.3. We're gonna do 12.2 and 12.4. Okay, fill in the table. I actually didn't use every single row. I used 3 rows. So if you want to just use 3 rows to answer both questions, go ahead. But you have to use the table in some capacity. So I would like you to start with what they give you. For Noah, they gave you 4 and 6, 4 tacos and $6. Start with that and answer the question, how many tacos could he buy for 15? When you're finished with that, I want you to go on to number 2, and I want you to test if Jada's price for the tacos were the same price as Noah's. All right? What's wrong, Taylor? We're on 12.2, dear. The only thing, we're doing 12.2 today and 12.4. I'm not going to skip anything that's in my plan. If there's anything in the book that you'd like to see answers for, just let me know, and then I'll show those to you. Brian does, okay. You don't understand? Well, we're going to finish the book, and we're going to test, and that's still up in the air about how we'll do that. Okay. Okay. That's okay then. Let me show you what I mean. So I started in the table with 4 and 6. 4 and 6 is exactly the information that they started with. What are they asking me for? They're asking me for what does it cost for 15, how many tacos can I get for $15? That's why there's a question mark under the 4. Take a look at how I filled out the table. Now, how do you get from 2 to 15? I'm sorry, that's a 6. From 6 to 15. How do you get from 6 to 15? If you take 2.5 and you multiply it by 6, you get 15. So now we have to go over to 4, and we need to multiply that by 2.4 also. That's how you get the equivalent ratio, right? Yes, you can actually also divide. You can do, I'll write it right here, 15 divided by 6, right? I put it right here. 15 divided by 2, 6, I'm sorry, because I'm reading it backwards. 15 divided by 6 equals 2.5. What's the question, Brian? So under 10, will it be 0.4? Under 10. Oh, okay. So this is something that I don't want you to stress about when you have tables. Don't stress about going in order. You know how on a double number line, we typically go in order? We go in order of the skip count. You don't necessarily have to do that here. Okay, Jesus, where did we lose you? Okay, cool. So now I need to hear from Jesus. Where did we lose you? the box and how much each taco is. Ah, we didn't talk about how much each taco is yet. Let's do that. In the table, since I have 2 blanks, let's get a unit rate. I want you to ignore the last one because my last row answers number 2 and it's Jada. Okay, it's not Noah. But right underneath the 10 and the 15, let's get a unit rate. Let's find out. Let's put the 1 under the 10 and let's find out for Noah, how much does each taco cost? How do we do that? How do I get from either 4 to 1 or 10 to 1? How do I do that? Yes, that's right. Let's divide. Good job, buddy. So 4 divided by 4 will give me 1. What's 6 divided by 4, folks? 6 divided by 4. Did you guys get $1.50? Fergie, try again. I need you to do 6 divided by 4, and you should get 1.5. Okay, perfect. That means that every single taco is $1.50. So does that help you out now, Jesus? That was a really good question, and it was something that I had put up here as a challenge because in number 1 and number 2, they don't actually ask you for a unit price, but I was going to end up asking you guys anyway. Okay, awesome. Thank you so much. Okay, now let's do number 2. Number 2 is about Jada. Jada also purchased tacos. She purchases 50 for $72, and they want to know, is that the same price per taco that that Noah is paying? So how can we find out? Well, the first thing that I did was I looked to see if I had equivalent ratios. That's one strategy. So I asked myself, okay, how do I get from 10 to 50? Well, just multiply by 5. And that's my 50 tacos. Then what is 15 times 5? Is it 72? No, I found it to be 75, which means that Jada is not paying the same price. Jada is not paying the same price. Now, Jesus asked us, well, how much is Noah paying per taco? And we found it to be $1.50. How can we find out what Jada's paying per taco? What should we do? Jada is not paying $1.50. Noah is. Jada's paying something different. So what I did was I drew a line here because I don't want you to get mixed up. Above the line is going to be Noah, and this is not typical. You wouldn't typically have the same table for 2 people. I'm just improvising here because we're not in class, right? Which actually I could put 2 tables right here if you want, and this is confusing. I could do that as a backup for you. So above the line is Noah, and then below it is Jada. How do we get Jada's 1 taco, the price for her 1 taco? How do we get from 50 to 1 or from 1 to 50? You guys have been telling me a lot to divide. So 50 divided by 50 is 1. So what is this number divided by 50? What is 72 divided by 50? Nope, the other way. Oh, yeah, the other way, Brian. 72 divided by 50. 72 divided by 50. You guys should get $1.44. Good. So she actually, nice job, guys. So Jada's actually getting a better deal. We don't know why, but they're not paying the same price, okay? Okay, nice job, guys. Awesome. Okay, now, do you have any questions about 12.2? Any last questions about this one? That was good stuff. Okay, cool. Then we are going to move on to 12.4. That way, if, because maybe we'll end up with time at the end, and if you have any questions on the MOBI, like area, surface area, the statistics questions, if you have any questions, I want to make sure that I can give you time to ask those also. They're scamming? No, it could be just because sometimes when you purchase more, the unit price is cheaper because you're buying it in bulk. So I don't know if they're necessarily scamming him. It could be a different restaurant. Who knows? I don't know. But we are on 12.4, folks. 12.4. Now, 12.4. The whole goal of 12.4 is to take a look at solving a problem using a double number line, but then when you're done, doing it on a table and trying to see which one you like better, and like what are maybe some drawbacks to one versus the other. All right. Okay. All right. So let's do this. Now, for number one, I want to show you something. It says that in 2016, 128 gigabytes of portable computer memory cost $32. Here's a double number line that represents the situation. And do you see how they have tick marks right there in the middle? They have tick marks, right? Let's see. Right here in the middle. Right there in the middle, it's cutting the double number line in half. So what's half of 32? 16, right? And then what's half of 128? What's half of 128? 64. So label, I don't want to show you the other part just yet, but at least label that part 64 and 16. Okay? Yep. Where are we getting 24 and 56 and 54 from? Half of 128 is 64. Maybe you didn't hear me right. That's a possibility. So make sure you go by what I wrote. 64 and 16. Okay? Make sure you write that down. Okay. Now I want to point something out extremely important that I don't think that we've made clear in class. Yes, we divided. We did 128 divided by 2 to get 64. And we did 32 divided by 2 to get 16. Because you see the space, right? The space. Where the tick marks are, where am I? Right here. That's halfway. This is the halfway mark between this number and the 0. It's right there in the middle. If you folded the paper in half, you would see. And that's what I'm trying to point out here, is that your double number line, ideally, the spacing should show the value of the number. So if I skip count by 5s, then it should, all the spacing, 5, 10, 15, 20, 25, all of that spacing should be equivalent. I shouldn't be making, right?
if I'm going to construct it and I want to count by fives, I shouldn't put my 10 all the way over here and then my 15 over here. This is not showing an accurate skip count by fives. You want to, and I know that, without a measuring tool, it will be hard to space it, but you can estimate it at least. At the very least, you can try to keep it consistent as possible. Okay? That's a lot more consistent than up here. Is it perfect? Not by any means. But it's much more consistent, and then I can adequately show 5, 10, 15, 20, 25, 30, 35. Okay? It shows the spacing is pretty much equivalent. And that's the goal with a double number line. So, why am I going through this, right? I'm going through this because you see how they're showing a half on the double number line? They want you to keep cutting it in half and half and half. So now I'm going to show you this. And do you see how every time I cut the number in half, the space also was cut in half? I want you to copy that down. And I want you to notice that even though I ran out of room on my double number line, you technically don't stop the rational numbers, right? You could keep cutting the fractions in half and half and half and half and half. We saw this with the coin problem when instead of the coin multiplying exponentially, it was actually getting halved. And it asked you, would the coin ever disappear? And the answer was actually no, it wouldn't, because you keep taking half of the number before. How are we doing? Are we okay? Done? Okay, excellent. All right. Now, that's the double number line. And I want you to notice which unit rate do I have on the double number line that I just showed you. Do I have the unit rate for the cost or for the actual memory? And I'll show it to you again. Which unit rate or unit price do I have on the double number line? I have it for how many gigabytes I could get for $1, right? Okay, well, if you take a look at number 2, number 2 wants to know how much it would cost for a gigabyte. And we don't have that information on our double number line. We have it how many gigabytes we could get for $1. They want the opposite. They want how much is it going to cost for 1 gigabyte. So let's find that out, and let's use the table to find that out. So if you have to turn the page, turn the page. And we're going to fill in the table the same way. I want you to keep cutting it in half, cutting it in half, cutting it in half until you run out of room. Would you do that, please? You think that it's going to be 4? Brian, let me ask you a question. Are you getting the 4 because of what's on the double number line or because of the table? Are you saying 4 because over here it says 4 gigabytes? I don't have a box. Did you turn the page, Jesus? I think you have to turn the page to the table. Okay, on the number line. Okay, Brian. We have to use the table to get how much for 1 gigabyte. Because the double number line is showing us for 4 gigabytes. 4 gigabytes, I pay $1. It's showing the opposite. Okay, I told you to fill in the table and to keep cutting in half, right? 1, 2, 3, 4, 5, 6, 7. A lot of it is already on the double number line, right? We already have half of 32. You told me that it was 16. You already have half of 16. It was 8, half of 8, half of 4, half of 2, half of 1 would be half a dollar. Half of a dollar would be 25 cents. Oh, Kareem joined us? Hey, Kareem. He got 4 gigabytes for $1, but we're looking for the opposite. We're looking for how much for 1 gigabyte, and we don't have that information. Right now, we have how much for $1. Let's continue. Cut that in half for me. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it looks like a couple people might be here that I didn't record, and I want to make sure I give everybody credit for being here. I have Brian H., Taylor, Jesus, Janelli, Jalen, Astrid, Avril, Nathan, Fergie, and Kareem. Is there anybody's name who I didn't call that is present in chat or on the stream? If there is, just please type your name or say hi. Christian, good morning. Perfect. I keep track of this stuff, so make sure you say something like present or here, something. Okay, and anybody else? Maybe not, because that's my 11. Okay, cool. All right, guys. Half of 128. You already had that. Can you see that okay? Okay, good. Half of 64. Half of 32. Half of 16. Half of 8. Half of 4. Half of 2. Boom. That's exactly what we needed. We needed 1 gigabyte. 1 gigabyte. We needed 1 gigabyte. What does it match with, folks? How much money? 1 gigabyte. One gigabyte matches with 25 cents. So if you're not sure, or there's a glare, I will show you this. We were interested in 1 gigabyte, not $1. The double number line showed us $1. We got 4 gigabytes for $1. But the question wanted to know for number 2, not for number 3, but for number 2. And I wrote it here so you could see the answer. It asked for the cost for 1 gigabyte. And remember, this was in 2016, it said. It was taking data and information. That's right, 25 cents. Good job, good job, good job, good job. Perfect. Okay, it looks like you guys got it. Now, number 3. Number 3 is asking your opinion. What would you prefer? The table or the double number line? And maybe a better question would be, what do you like about the table? What do you like about the double number line? What don't you like? I think that might be a little bit better because some people might be more comfortable with a double number line. Some people might like the table better. I think we're going to be using tables a lot more. I told you this while we were in class. Brian, you prefer a table? Okay, cool. Why? I can't see, it's too blurry. The board or the paper? Which one? I prefer to let me try closing the blinds. I think there's a glare. All right, is that a little better? What did he say? He said the paper was blurry. Okay, let me try again. Maybe I was here. Is that better? Here, is that better? Roy. The green part is hard to see. Okay, I won't use the green anymore. Can you see it on the paper? Because on the paper is the same exact thing. Okay, cool. Nice job, guys. Thank you. Thank you. Hey, we're up to 13. This is amazing. 14? Stop playing with me. This is great. Okay, cool. All right, so we actually accomplished our goal. We did our warm-up. I'll remind you what we did. We were supposed to do our warm-up. We were supposed to go over our homework. We were supposed to do 12.2 and 12.4. Now you guys have what you need in order to get done on Google Classroom. It's been posted for quite a while. Unit 2, Lesson 12, the classwork. It's the last one to prepare for our test. You guys have everything that you need to do now to get that classwork done. So that's due tomorrow. At this time, we still have 6 minutes left. So if you have any questions at all on a problem in MobyMax, a problem on any of our classwork or homework, please tell me now. All right, so is Royman really here? Royman, are you here? Because if you're here, I have to write you down. Okay, perfect. Thank you, buddy. Okay, I think I got everybody. Kareem, yeah, I got your name down. Awesome. Any questions, guys, on any work that you've been working on? Are we okay? All right, guys. Then yeah, I will see you tomorrow, same time. All right. Thank you, guys. If you have questions, please prepare them and make sure you ask me, okay? I'm here to help. All right. Bye, guys. Good job today.